This is going to be your makeup lab for chemical periodicity. What you're going to be looking at today are the elements that are colored green on the periodic table. And the question is going to be, in what direction do they get more reactive? So one way we can talk about reactivity is across a row or a period. And so we're going to figure out, do they get more reactive as you go to the right or as you go to the left? The other part of the trend is to determine if they get more reactive going up the column, aka a group, or do they get more reactive as you go down the column? So the way we're going to test that is we are going to take and react these elements. So here's how they're laid out on the periodic table. These are just beakers of water, and we're going to see what they do when we put them in water. So the first one we're going to put in is sulfur. So this is just in a beaker of water. Sulfur is a yellow, dull colored powder, and you can see that it's not really doing anything right now. So for sulfur, we're going to say that there's no reaction there. The next one we're going to look at is going to be aluminum. So we're going to take and put in a piece of aluminum metal into the beaker there. And once again, nothing is really happening. So no reaction there either. The next one over, so these elements are all in the same row on the periodic table. They're all in the same period. The next one we're going to look at is going to be magnesium. So we're going to take a pinch of that and put that into the beaker. There we go. And once again, nothing. So now we can't really determine how reactive they are in a period here. So we're going to revisit these in a minute. We're going to get back to these. Next, we're going to look at a piece of calcium. So we're going to take a piece of calcium, which is actually a metal, and we're going to scoop it into that beaker right there for you. And you can see that it is reacting, it's bubbling, and the piece of calcium is dissolving. This is making a gas, and the gas would be hydrogen. Not that that's terribly important. Okay, let's move on to sodium. So we're going to take a little piece of sodium metal and scoop that in there. And I'm going to try to kickstart this reaction a little bit because sometimes they take a minute to do the thing. And so there we go, there's sodium. Now it's kind of skating along the surface there, doing its thing. So seems to be a pattern emerging now. Calcium did react, sodium reacted. Now we're going to take a piece of potassium and put that in. So let's give it off a purple flame. And there you go. So that was potassium. Okay. So we have a bit of a pattern here, but like I said, we need to take a look at these three again. We don't really have a pattern in these three because they all did nothing in water. So what we're going to do with these is we're going to react these three in acid. So in these beakers is hydrochloric acid, and we're just going to add the same elements to them and see if they do anything this time. So once again, we're going to start with sulfur, put that in there, and then we're going to put some aluminum in next. So if we take a look at the sulfur now, we see that once again, it's not really doing anything. So that would be a no reaction for that one, not doing anything. Okay, so then we'll put the aluminum and then we'll put the magnesium in. Okay, so you can see the magnesium is definitely reactive. Of the three, you can predict which one's most reactive. For the aluminum, it doesn't really seem to be doing much, but if you look at it really, really closely, you can see that there are some really tiny bubbles that are coming off. So this is reacting. It's just that it's a little slower than the magnesium. All right, so based on this, again, what the goal is to now say, do they get more reactive as you go to the right or to the left? And do they get more reactive as you go up the column or down the column? I hope you've enjoyed this lab. Take care.